Hello. Okay, so it says solve using the energy conservation or by solving differential equations. Yeah, let's just do energy conservation. So we see that there's a spring above and there's a weight. So of course there's potential energy, but it's at rest right now, right? So no kinetic energy, no chemical, no electrical, you know the rest, we're mechanical engineers, so. And then it's like purely potential. And then let's assume, or let's picture in our minds, since there's not a picture, that when the spring drops, so it's gonna turn to kinetic and then it's gonna whatever. But we're gonna stop the time at like when it's compressed, right? So there's no kinetic energy since it's not moving. And the weight is pushing down on the spring, so it's purely spring, right? So yeah, let's equal the potential energy and the spring energy equal to each other. So the weight, W, which is, what is it, mass times gravity, which is weight, right? mgh. So the h is the height of this, plus y max, and then, let's see, what are we even solving for here? I'm gonna look. Oh wait, you were solving for y max, right? Okay, so yeah, cool. And then equals to 1/2 k, the spring constant, right? And then times y max squared. I guess y max is the compression, right? So, and then they give us, I guess it's kind of chalked. Shoot, it's kind of blurry, whatever, but we can't really see it. But it says W equals 30. Let's say K equals 100, and then H equals 2. So they give us 30, or they give W, H, and then K. So we plug those all in. So we just distribute, right? So 60 plus, or distribute the 30 to 2, 60, and then it's 30 to y max, 30 y max. 1/2 times 100 equals 50. Yeah, sorry about that. So y max, and then yeah, so then we have y max squared. Yeah, looks like they gave it all here. And then yeah, so this is a quadratic equation, right? So we just move this onto the other side. So 50, or let's move this on the other side. So 50 y max squared minus 30 y max minus 60 equals 0. The common multiple is 10, so just divide by 10, and then 0 divided by 10 equals 0, right? So y max squared minus 3y max minus 6, that's a quadratic equation. So from here we can get a equals 5, b equals -3, the coefficient, and then c equals -6, the constant. And then we just use quadratic equation. Let's plug it in. And then yeah. So after we do the quadratic equation, we get this. We're left with the dilemma, plus or minus, right? But what's such thing as a negative deflection, right? So we're gonna assume that we have positive deflection, meaning that the plus is the only option. So once we plus it, 3 plus square root of 129 over 10 equals y max deflection equals 1.438 inches. Yeah, and then let's see. Yeah, so that's the maximum deflection. I'm pretty sure the question also asked for the force. So the spring constant times x, the deflection, and 100 times, or they give us 100 right here, or not here, but in the question statement, and then 100 times that, the deflection, equals this. So this is how much spring force there is at the maximum compression. Thank you so much for watching. Make sure to like, subscribe, and turn on the post notification bells down below, and comment your favorite part of the explanation. Thank you.